Good morning. So we finally are on the last day of 5-2. So what you have left is the review. I'm sure everybody got my message that there's going to be a quiz on Tuesday. It has 5 problems on it. You'll get it at 7:30 in the morning. It's due at 1 o'clock in the afternoon. So you can read my message on Google Classroom about that if you haven't already. So what I want to do is work through problem number 1 on the review sheet with you, talk about a couple other problems, and then from there, I'm actually going to post my answers to the review, just like I normally would do. So you do not have to turn that in on Google Classroom. You just will be able to use this video and use my answers. And then if you have any questions, you can certainly email me or write on Google Classroom and I can explain anything. But you'll have my answers as you're working through it. Like always, try to do the problems before you open up my answers though, because you don't want to give yourself a false sense of what you know or don't know. So I'm choosing to do problem number 1 for a couple different reasons. First, there's a method that I know we've talked about in the past, but I just want to make sure I reiterate it here because you can use this specific method to do a couple of the problems on this practice sheet, and most likely one of the ones that I'll give you on the quiz for Tuesday, so you want to pay attention. The other reason I chose this one is because when you look at this problem here and you want to work on the left-hand side, you're probably thinking of how to make the denominator into an identity. At least I hope that's what you're thinking. And the only identity with secant would be one using secant squared. And that identity is that tangent squared is equal to secant squared minus 1. And the reason I'm pointing this out is because if you did decide to rewrite the denominator as secant plus 1, switch them around, and then multiply the numerator and the denominator by secant minus 1 to get your secant squared minus 1 in the denominator, I think you're going to end up getting yourself into a lot of trouble, and it's going to be a lot of tough algebra to try to get yourself out of it, which is why in this problem, I would change them all to sines and cosines. Now, let's say you did the other method first. It's fine. You cross it out when you realize that you can't get any further and you can't get your identity to equal sign. You cross it out and you start over, and then maybe you use this method that I'm going to show you right now. So we talked about how when all else fails, and only when all else fails, we change everything to sines and cosines. That's what I would do in this problem. Another reason why I would change into sines and cosines is because I'm trying to get this to equal the sign. So I know I need to have sines and cosines anyway. So I'm going to change this. So I have sine theta plus tangent is sine over cosine over 1 plus secant, which is 1 over cosine. Okay, a method that we have used multiple times this year is if you have a complex fraction like I do here, you can multiply every term by an LCD. So I look and I see the denominators that I have are both cosine. That's good. So my LCD is cosine theta. I'm going to multiply each term by cosine theta. And what that will do is it will eliminate the complex fraction and just give you a single fraction. So I multiply the sine by cosine theta. So I have cosine theta, sine theta. I multiply this term by cosine theta. Well, in this term, the cosines are going to divide out, and I'm just left with a sine theta. Okay, I multiply this term by cosine theta. Cosine theta times 1 is just cosine theta. And now I multiply this last term by cosine theta. And again, the cosine theta is crossed out, and I'm just left with a 1. Okay, from here, you might try to use an identity, and if you do, it'll probably work. However, The easiest thing to do from here is, if you notice in the numerator, you have a sign in each term. So you can factor that out as a common factor. So it's like my GCF is sine theta. If I take a sign out of each of these terms, I'm left with cosine theta plus, now don't forget, if you take a sign out of a sign, you're still left with a 1 here. Doesn't disappear. We talked about that. Over cosine theta plus 1. Now, sine theta is a factor. Cosine theta plus 1 is a factor. This cosine theta plus 1 is a factor. Since they are factors, we are able to divide them out. And now I'm just left with the sine of theta, which is what I wanted. Okay? So that method you should try on problems 3 and 5 as well. Okay. For problem number 2, I would change them all to sines and cosines and then distribute the sine x, cosine x, because you have, and I'll write this out real quick for you. This sine x, cosine x is just a single term. So again, change the tangent and cotangent to sines and cosines and then distribute. Or you could always distribute and then change them all to sines and cosines. Okay, so that's going to be your method to do number 2. So I told you 3 and 5 are going to be like the number 1. 2, I just gave you the method for. So then you have 4, 6, 7, and 8 to try on your own. Again, I'm posting the answers to all of them along with this video. If you still have questions, please just let me know. Have fun.